Alright, today in section 6.2, we're going to use proportions to solve geometry problems. But before that, let's kind of recap a little bit of what we did last time. In that section, we learned about cross products. So if you had A over B equals C over D, then we learned that, hey, you could take these two, B, C, multiply them together, and they're going to be equal to the product of the other two, A times D. So that's what we learned last time. Now here's three additional properties of proportion. That's right, not one, not two, but three. And so these, if you look at them, you're like, oh my gosh, there are all these letters and I have no idea what's going on. So one of the things you can do sometimes when you've got formulas, plug some numbers in there and just play around with it until the formula makes sense for you. Then after a while, that'll help you get it memorized. So what I'm going to do is I'm going to take this first one. A over B equals C over D, and I'm going to let A over B be 1/2 because that's a fraction everybody's pretty familiar with. Now C over D, I'm going to let that be some other fraction that's the same thing as 1/2. Say 4 over 8. Okay, no big deal. So that's what I have to start out with. Now after that I've got then B over A equals D over C. So what this really says is, well, okay, why don't I just flip it? So I'm going to take the reciprocal of each side, and that's going to be 2 over 1 is 8 over 4. Well, let's kind of check that out. If I reduce 2 over 1, yeah, I end up with 2. Now what about on the other side? 8 over 4. If you simplify that, you also get 2. So, well, yeah, that kind of makes sense. So that's what this first property means. Just take A, B, C, and D, each one of those fractions, and just find the reciprocal of each. Just flip them. Now in our second property of proportions that we've got here, what we're going to do is instead of going and taking the reciprocal of each function, what we're going to do is we're going to look going across. So here, where we have the A is in the numerator and the C is in the numerator, we're going to take those and make a fraction out of those two. So again, we'll use the 1 over 2 equals 4 over 8 part. So 1 over 2 equals 4 over 8. So say that's my fraction when I start out with. So if I go across, and I'm going to have A over C, well, okay, so that means I'm going to have 1 over 4. And then the other part, B over D, well, 2 is in the B spot and 8 is in the D spot. So if I think about those, there's a couple different ways you can kind of process it. One, like if I were to change 1/4 into a decimal, well, that's just a quarter, or 0.25. 2 over 8, well, that reduces down to a quarter also, or is the same thing as a decimal, 0.25. Well, yeah, that's equivalent, so that kind of makes sense. No big deal. Now our third one, we've got A over B equals C over D, then A plus B over B equals C plus D over D. Now this one's probably the newest and probably the most confusing of all three of the new ones here. But let's just kind of keep that idea here. We'll use 1/2 equals 4/8. Now what this other property says over here is A plus B over B. Okay, so in the bottom, I'm going to have 2 still, but on the top, I'm now going to have 1 plus what's in the denominator? 2. So that's what I'm going to have on the left side. Now on the right side, I'm going to have C plus D over D. So my C value was 4, so I'm going to have 4, and in the denominator, the other one was 8. So 4 plus 8 over 8. Ugh, yuck. So if I take these and kind of simplify them a little bit, I'll have 3 over 2 on the left side, and then 4 plus 8 gives me 12 on the right side. Now again, there's a couple different ways that you could simplify this to reduce it if you wanted to. 12 over 8, if I were to reduce that, that would simplify down because 4 goes into the numerator and the denominator. 4 is a common factor. So 4 goes into 12 3 times, and 4 goes into 8 2 times. Well, then if I just bring the 3/2 down, you can easily see, well, yeah, 3/2 equals 3/2. Well, okay, yeah, that makes sense. So I don't know really what's so hard about that. Why they got to make everything so confusing and write a formula like that? Ugh, yuck. But one note here, you probably won't see your fraction when you write it. You won't see it written as A plus B over B, or in this case, 1 plus 2 over 2 equals 4 plus 8 over 8. You'll see it written in the second row right here. So that's what it'll look like. And it'll be kind of confusing in the beginning, but then after you see a few of them, I think you'll be all right. So I just wanted to kind of break that piece into you before we get into some of our examples. In this diagram, we're given this proportion, mn over rs equals np to st. Write 4 true proportions. Well, when we take a look at this, there's a couple different ways that you can do this. You can do this, 1, just using the variables, or 2, you could use it with the actual segment length that we have. So I'm going to just stick with kind of the letters here to start with. If I'm given mn to rs, alright, so if I do the first property where I just invert them and take the reciprocal of each side, then that means rs over mn is going to be, well, what would the second fraction be? Yeah, I'm pretty sure you know what it is. That would just be st over np. So that's one possible proportion. Now a second proportion would be if instead of just taking the reciprocal, say this is the one where I went across. So if I start with mn and then I go over to np, then in the other fraction I'm going to have rs over st. So that's if I started and went across. Now this third one, this is one where you've got to add something in both the numerator and the denominator. What you've got to remember is that whatever the denominator is, that's what you're going to add in each piece. So in the fraction on the left, the denominator, well, that's just rs. Okay, no biggie there. In the fraction on the right, st is your denominator, so you would just add that there. So that wasn't so hard. I don't understand what the big deal is. Holy moly. You just have to remember to flip things around. Now, one of the things that I like to do, when I'm taking a look at these, is I like to actually put my hands on the pieces and kind of touch them and move them around. So I know I did that using the arrows, but what I want you to do, maybe on your paper if you're doing that, if you have to draw this, that might be one way to help you kind of remember it, is to just go ahead and put your hand on each piece or put a finger on each piece as you go through and do that. So that's just a non-technology tip that might help you a little bit. Now my fourth proportion is going to come from if I actually started to use the numbers and the variable x that's in there. So if I started here, let's kind of start up with my original one. My original one, mn, well, that's just 8. So I would have a fraction of 8, and then rs, well, rs part, that's just 10. And then my the other piece of the proportion, np, so the np piece is 4, and the st part, that's just x. So that's one of the pieces that I could have, and that would just be from the beginning one. So that could be proportion number 1. And then if I have them flipped around over here, the other way I could write this one, if I use those numbers and the letter x, then I would just have that as 10 over 8 equals x over 4. Alright, that's no big deal. This one I would write as, so the mn part, well, that's 8. np, well, now that's 4. And then the rs piece is 10. And the st part, well, that's our value, x again. So that could be a third proportion almost now. Even though I've got a number 2, that's really this third one if we start using the numbers 8, 10, 4, and the variable x. And then our very last one, this is one that's kind of funky a little bit. So let's kind of take a look at it. If you take a look at mn plus rs, so mn is 8, rs is 10 over 10, and that'll be equal to np, which has a value of 4, and then our st, we don't know what that is. That's just our value of x, and then over st, that's x again. Generally, you won't see it written like that, but instead, you'll see that written as 18 over 10 equals 4 plus x over x. So sometimes when you're adding two numbers in the numerator, you'll clean that up just to have one single integer instead of two integers being added together. So those are the 4 different integers you've got, or 4 different true proportions that you could write. 8 over 10 equals 4 over x is your first one, and then we've got 10 over 8 equals x over 4 is our second one, and then we have 8 over 4 equals 10 over x, and then lastly we would have 18 over 10 equals 4 plus x over x. So there's 4 true proportions that you could write. That's no big deal. But what I want you to do again, if you need to, go ahead and put your fingers on those pieces so that you can see kind of how those proportion rules start to line up. All right, that's it for this example. Example number 1. Now let's take a look at this guy here. Check him out. In this diagram, and this is what's true a lot of times in geometry, they'll give you a proportion, so you don't have to come up with one on your own. They'll give you one, and then they'll ask you to find certain information. So we're told like BD over DA equals BE over EC, so that's going to be the proportion we've got to work with. Using that, we've got to find BA and BD. Well, when we take a look at this, BA, well, that's the entire length of one side of the triangle that they're representing by the letter X. The BD part, well, from B to D, I don't know what that is, so I'm going to have to do some stuff to help me figure that out. So let's kind of play around a little bit with what we've got written down in our proportion. We've got BD over DA, so let's see, BD, do we know how much that is? No, so that's going to be an issue, and we'll figure out how to solve that in a second. But the DA piece, well, DA, I know that part's 3. All right, so no big deal. And then the BE piece, well, we can see the number 18 sitting there, so all right, no biggie. And then EC, well, yeah, that's just 6. Bam! So we've got all of that. Now for BD, I don't know what BD is, but using this piece that we're given right here, there's a couple of different ways that you can go about this. If the entire length of BA is X, then this piece right in here, from D to B, well, that's just got to be X subtract 3. Like, I don't know how long the one piece is, but I know the other piece is 3. So I could use this expression here and say, well, that's X minus 3 for the length of BD. Once I know that, from here, there's the cross product property, what I'm going to do. So I'm going to multiply these two together, 3 times 18. All right, that's pretty straightforward. That'll give me 54. Now on the other one, depending on your level of skill with this, what I like to do first is write down 6 and then X minus 3. If you're really good at that and you can do that mentally and make sure you don't make a mistake, then you can go ahead and distribute the 6 to each term, in which case you would get 6X minus 18. Either way, make sure you write out one of those two equations. If you need to write out the first one, no big deal, take your time. I'd rather you get it accurate than make a careless mistake, because a lot of times people will just write 6x minus 3. That's wrong. And you'll go through all this work and then be frustrated because you made a careless arithmetic mistake. Don't be that guy. All right, take your time, get it right. Now, if I add 18 to both sides, I'll end up with 72 equals 6x. All right, now, the thing that I want to do next to solve for x, I want to divide both sides by 6. So when I do that, I will get a value of 12 for x. All right, so I'm done, right? Psych, look at that, man. See, and this is one of the things that kills me in geometry. People don't read the question. It says find BA and BD. Well, all I did was find x, so I don't know anything yet. So if this whole thing is 12, so I just figured out that the length of this whole piece right here is 12. So now check it out. I just found that x was 12, so I know that piece. Well, what does x represent? Well, that's the length of B all the way down to A. So I do know that piece. So BA, well, that's pretty easy. That's 12. I know what that is. Now to figure out BD, this is where you have to use your subtraction skills, man. And come on, you got that. If the whole thing is 12 and the DA part is 3, that's just 12 minus 3, so BD would have a value of just 9. All right, so take your time. Make sure that you go back and answer the question, because I hate it when people get so frustrated, like, oh, I made a careless mistake and I didn't read and find out what I needed to. So come on, take your time and make sure that you reread the question and get after the information you need to. Pretty easy once you make sure that you read everything, go through your algebra correctly, and simplify and solve the problems. Not too bad. Now let's get into some real applications of where you're really going to see proportions in real life. And that's going to be in models, drawing and diagrams that represent real life things, but in paper, you can't represent things so bad. So check it out. We're going to talk about scale drawings. And a scale drawing is a drawing that is the same shape as the object it represents. Now we've got another vocabulary word here called scale. And scale is a ratio that describes how the dimensions of a drawing are related to the object that it represents. Well, that kind of makes sense. Now let's play around with this one about the 3D model of the Reunion Tower in Dallas, Texas. If you ever go to Dallas, you totally have to check this thing out. There's a nice picture of a sunset around here of that place. I mean, it's just gorgeous. And the view from up there, holy cow, it's amazing. So definitely check that out if you get a chance to, if you're ever in Dallas. Now, in the problem, they say the actual building's 560 feet tall. So we got a model that's 10 inches tall, and the diameter of the dome of your scale model is about 2.1 inches. So we got a bunch of numbers in there, and we've got to use those numbers to help us figure out two questions here. One, what's the diameter of the actual dome? And two, about how many times as tall as your model is the actual building. One of the things I like to do when you are given the information in this picture, the actual model of the building is 560 feet tall. So I'm going to write a proportion here, but before I even write the proportion, I'm just going to write the word actual and then the word model, because that's going to help me kind of keep straight what's going on. Now the actual building is 560 feet tall. And our scale model, they tell us how tall that is. They say the model is 10 inches tall. They also tell us that the diameter of the dome is, on the scale model, is 2.1 inches. So when I take a look at that, I always want to, and this is why I write the words actual and model, because they say that the model is 2.1 inches. So the main thing I've got to do is make sure I put that 2.1 in the right slot in my other fraction here. So 2.1 would go here. Now another clue with that is that it's in the same unit as the model is. Both the model units are inches, so that's one thing you could look at too. Now the actual diameter of the dome, I don't know what that is, so we're going to let x represent the actual diameter of the dome, because we know the diameter on the scale model, that's 2.1. Now here, this is just going to be some cross multiplying and dividing, and you've got this figured out. Now our dimensions of the actual would be in feet. So now you know how to cross multiply and divide this. So all I want you to do is go ahead, cross multiply, divide, and then come back and check your answer. So go ahead and hit pause now and work that out and come back and see if you got it right. So how did you do? Hopefully you got that right. Yours might be switched around, where instead of 10x on the left, you might have the 1176. But in either case, you should end up with x equals 117.6. Now, here's one other tip. Write a sentence that answers the question. I know for my students, I require them to do that. So make sure that you not only set up a proportion, solve for x, but then last, write a sentence to answer the question. And then when you guys write your sentence, what I want you to do is make sure that you include the unit that you just found, the unit of whatever the object was, because you've got to have that part in there. So that's that first piece that we did. What is the diameter of the actual dome? Well, the diameter of the dome is 117.6 feet across. Now, for the B piece, so let me go ahead, I'm going to switch colors here so we can kind of keep that separate. Now for question B, this is asking us about how many times as tall as your model is the actual building. So again, I'm going to use this actual to model. I'm going to write down these two words. Now our actual building was 560 feet tall. And our model is only 10 inches tall. Now, when I take a look at this, I've got to take a look at my units here. And my building is 560 feet, but the model is in inches. So I've got feet and I've got inches. Now, what I want to kind of do is take a look at the units on here, because this is what, I know in chemistry they call this dimensional analysis a little bit. And in geometry, you don't really refer to it as dimensional analysis, but you'll kind of get the idea. It's the same thing here. Now, one of the things you've got to know that in 1 foot, there are 12 inches. So now what you want to do, because we're going to set those two numbers up, 1 feet and 12 inches, we're going to set those up here in this other fraction. We're going to multiply by that. And what you're going to want is to get all of your units to cancel out. So that means in the top, see I have 560 feet, so that means I'm going to want feet to go in the denominator of the other one. So that's going to just be 1 foot. And then my 12 inches is going to go on top. So then that way, when I multiply, inches are going to cancel out as well as feet. So all my units are going to be gone. And then all I have to work with now is just the numbers. So when you take a look at it, when you multiply across, you'll get 6720 over 10, and then that's really easy to deduce because all you're going to, or reduce, because all you're going to do on that is you're just going to cancel out or take out the 0 on that. And so you're left with 672. Then again, don't forget, write a sentence. And anytime I get stuck with how to write a sentence, all you need to do is look back at the original question and rephrase that question. The question said about how many times as tall as your model is the actual building. So we just rephrase that and say the building is 672 times as tall as our model. Done. All right, nothing complicated about that. So that's all you have to do working with these kind of problems and solving proportions to work with solving some different geometry problems. All right, it'll take a while and take a little bit of practice to get some of those properties down, but play around with the numbers and you guys will be fine on this. But we're going to use a lot of these proportion problems and properties throughout the rest of this chapter in geometry. All right, that's it. Thanks for watching, and you guys have a great day. Peace.